Greetings and welcome, friends. We were talking about areas of polygons, and with these areas of regular polygons, we kind of also dealt with these inscribed circles and things like this. Also, the idea of Boolean subtraction, kind of taking the big area minus the little area gives you the other little area here. So the area that I'm trying to find today is this sliver. This is like the crust of the pizza sector, right? Right there. And it looks like they labeled what would have been an apothem of... What shape would this be if I duplicated this triangle and rotated it around, fitting all the pieces together? It would have been a hexagon. How do you know it's a hexagon? The 60 degrees of the arc measure will also correspond to the 60 degrees of the central angle and the central angles of that hexagonal shape would have that. So I think what I can do is take the area of a sector and subtract the area of this triangle. Man, that's the saddest looking 60 degrees I've ever drawn. Or these are the radii. I don't know if you guys know that. And that's going to equal my little pizza crust slice over here. All right, there's the saddest subtraction area addition drawing ever. So to find the area of the sector, I'm gonna need to find this radius. So let's actually figure this out. I'm gonna scale up this. All right, so if 60 degrees is the arc measure, we already said the central angle was 60, therefore half of that would be 30. Right? And if this is 2 square roots of 3, question, comment? Wait. Someone's talking, Isaiah, please. To go from the longest leg to the shortest leg, I would divide by the square root of 3 and get 2, and then go from the shortest leg. Not without knowing, I guess, yeah, if you're just, like, familiar with equilateral triangles and you saw the height had a square root of 3 in it, yeah, you could've. You could've. What's up, question? What I did to go from, here to here, I divided by the square root of 3, and then to go from here to the hypotenuse, I multiplied by 2. You also could have done that using trigonometric ratios, using just, looks like cosine of 30 degrees as well as tangent of 30 degrees. Would have helped you find those dimensions. But either way, you find them one way or another. As far as these dimensions are concerned, this is the apothem, and this is the radius. So if I want to find the area of this is a radius of 4 and a central angle of 60 degrees. So I'm going to use the area of the sector. I don't know. I'll just call that cap x, I guess. X over the area of the circle, pi times 4 squared, is going to equal the angle of the sector divided by the angle of the circle. So that's going to be x over 16 pi is equal to 60 over 360 reduces to 1/6. And then multiply both sides by 16 pi. Now, even if you couldn't do this setup, if you could draw me like that picture, like I did earlier, then I would be able to give you partial credit on quizzes and such, you know? And that'd be nice. Question, comment? Yeah, so I would try to reduce, both 16 and 6 are reducible by 2. 2 goes into 6 3 times and into 16 8 times. So it looks like 8/3 pi is the area of the sector, and you could get a decimal approximation of that. Now, regarding the area of this triangle, well, I happen to have, I don't have to use the area of a regular polygon and all that stuff. But here's the height is 2 rad 3, and the radius is 4. So I'm just going to use half base times height. So half the... Oh, wait. Oh, if this is 2, then the entire base is 4 as well, yeah. So half of 4 times the 2 rad 3. Don't just think of height as having to be a vertical dimension. It can be, depending on the orientation of it, right? You can imagine it different. So half of 4 is 2. 2 times 2 is 4, so 4 rad 3 is the area there. So the overall area of this sector is 8/3 pi minus 4 square roots of 3 units squared is the exact area. And then you can find a decimal approximation of that if you want, which tell you what, we'll just, yeah, 8 divided by 3 multiplied by pi. And I get 8.378 minus 4 times the square root of 3. There are multiple ways you could do this, yeah. And so A is going to equal approximately 8.378 minus that. And I get 1.44450 units squared. All right. It is possible you could have imagined an entire hexagon here and subtracted from the entire... Actually, yeah, let me just draw that out. What if I took the entire circle and I subtracted the area of a hexagon? Yeah. And I did 1/6 of that. That would also equal my pizza crust. Right. So there are multiple setups that you could do, and some of the gallery walk activities you guys did earlier were similar to that. Want me to do this one? Which I assume, just like when we looked at the formation of snowflakes and the hexagonal shapes that those produce, that I'm guessing that basalt chemically at an atomic level has probably similar formations, and is probably why these form hexagonal columns, along with actually a lot of crystal formations that can happen in geology. So Basalt Ecommons are geological formations as a result of rapidly cooling lava. Giant's Causeway in Ireland contains many hexagonal basaltic columns. Suppose the top of one column is in the shape of a regular hexagon with a radius. Oh, no, they didn't. Let's see. All right, so with a radius of 8 inches, so let's see. So the radius goes from the center to where? To a vertex, right? So if this is 8, and then I need to find the apothem and half the side length, which sometimes I just call that x, and then the entire side length is that. So chances are you guys might need to practice just some of your right triangle trig to be able to figure this out. How could I find the central angle of this? Yeah, 360 divided by 6 would be 60. Yeah, 30. Oh, so then I can actually figure this out without using tan or cosine. So this is going to be half of 8, which is 4, and this is going to be 4 times the square root of 3. Right? Question, comment, Isaiah? All right, hi. So the area of this would equal half the apothem times the perimeter. If this is 4, if this length is 4, then the entire side length is 8, right? And 8 times 6 would be my perimeter. So I'm going to get area is equal to half the apothem, which was 4 rad 3. Probably 4. Oh dear. Rad 3. Yeah, 6.928. Yeah, give me some more decimals than just 1. And then, yep, cool. And then perimeter is 8 times the number of sides. So it looks like half of 4, so that's 2 rad 3, and 8 times 6 is like 48. Right, 48. And so I get 96 rad 3. Nope. Yes. So that's the area exactly in inches squared, or squinches as I call them. Yeah, squinches and squentimeters. Try using that in a lab report sometime and see what you get as a response. Uh, 277 inches squared. Right, so you don't want to, you want to save your rounding of decimals as far into the end as possible. But there you go. I'm not, okay. Oh, find the area. Oh, thank you. Thank you. To the nearest square inch. Good save. So the answer would be 166 inches squared. Good save. Wow. Which, by the way, when I was playing Dragon Age Inquisition on the Xbox One, there's a whole level where you're on like a coastline with, I assume, basaltic columns or something near equivalent. Have a great day, internet friends. Bye-bye.